You are welcome back to a session with your friend Edu. And welcome back to my channel, Mathematics with Edu. Please don't forget to subscribe. Press the subscribe button, like, make your comment. I would appreciate this, and equally share with your friends and others that will be of need to, especially students. Now, like I promised, we'll be taking an encompassing example on binary operation. I've explained the concept, the properties, and how you can apply them. Now, we are applying them now. So let's quickly go together. The question on the board is a standard question. In fact, for any entrance exam, the theory section is a whole question. So you have a binary operation. This is defined on the set, of course, is real numbers, by x operate on y. This is the definition. This is what you need in this whole of this video. This is the only thing you need. So you need this. So it's defined by that, where x, y belong to set of real numbers. A, determine whether or not the operation is commutative. Don't forget what we gave as a definition of commutativity. We said an operation is said to be commutative if there exists two elements such that the operation of the two elements together, those two elements belong to a particular set, not a non-empty set, a defined set, of course. So you have, let's say, if x plus y should be equal to y plus x, provided where x and y belong to, let me say, a set of real numbers. So therefore, this should be equal to this. This is the definition of commutativity. So this is what we are going to be using here for this expression. So let's use it. We have been told that we should show that it is commutative, right? So x has steric y. What would that be? This x operates this. How do we show that it's commutative? Do we have any other information there? We don't have any information. So since we know that x operates this y, it will give us x plus y minus 2xy. Then we should look for this. Y operates x will definitely be what? Y. By this definition, we must stick to the definition. Definition is like a structure that is in place. So we follow that structure, follow the pattern. So here you have y plus x. Then minus what? You have, because y is operating x now, we're going to be having 2yx. And for the knowledge of our commutativity, x plus y is the same thing as y plus x. This is a minus, of course. It's not affecting anything. This is a product of 2 and x and y. So we have a product of 2 and y and x. xy is the same thing as yx. So which means already this is equal to this. And this is equal to this. So this implies that what? The operation this is commutative over the set of real numbers that have been given over x and y. So define is commutative on this set that is being defined. Question 2, B. B says, find the identity element of the set of real numbers on this operation. So if you are, don't forget again from our definition of real numbers, identity element. I said if you are defining an identity, you have, I use A in my own definition, right? So I have A, asterisk of E. That should still give me what? Should still give me A. Do you get? So by now we must follow this definition again. That's why I did this to this. I put this in an enclosed box. So if you have X operates Y giving us this. So I can say X, if X operates Y give us this, what will X operate identity element? What will it give us? It should give us X plus, instead of Y, you have identity element, then minus 2X multiplying identity element, right? And anything you operate with the identity element will still give you that element by this one I wrote here. Don't mix it up. Anything you operate with the identity element will give you that thing. So it means if I operate X on this my identity element, I will still get X, right? So which means this one is supposed to be equal to X. So I can now write this down, and I don't have business with this again. This is what I need now to get E. So I can now write X plus what? E is my identity minus 2XE. That will be equal to X. Then here you can say E, collecting like terms, 2XE can be equal to X minus X. This comes to this side, or you subtract X from both sides. This is gone, right? So let me manage this, please. Finish up. So you have E minus 2XE to be equal to 0, right? So here you can factor out something here, of course. 1 minus 2x. That will be equal to 0. So here our identity element will be equal to 0 divided by 1 minus 2x. So that means our identity element is equal to 0. And of course we have two identity elements. We have two identity numbers, 0 or 1. This shows we are correct. So here we have this to be 0. Now we can solve the next question. Please get that straight. The next question will be what? The inverse. That is question C. Find the inverse of a general element P, where P belongs to R. Okay. I should have written something in terms of P here, but okay, you are assuming P belongs to R, so I can change any of them there. Yes, I can change any of them there. Just look at my explanation. So for identity and for inverse, I define that A asterisk A inverse should be equal to what? The identity. We've gotten our identity. Don't forget, identity is 0. Yes. So yeah, they are telling us to use P here, right? So I can, instead of X and Y, I use P. So P operates P inverse. That should be equal to E, right? So since we are following this definition, we stick to it. So we have what? We have P operates P inverse. That will be equal to P plus P inverse, right? Minus 2P P inverse. That is 2 times P inverse. And of course, this is supposed to be equal to our identity element. So we can now write our business with these two now. I can now write P plus P inverse, the inverse of P, I mean, then minus 2P P inverse. That will be equal to 0. Don't forget we are looking for our inverse, and this is our inverse. This guy is our inverse. So here we can say, what can we do now? Okay, these two, we have family members here, right? So we can release this guy to go. P, you can release P. So we have P inverse minus 2P P inverse. That can be equal to minus P. So after getting this, what do? You factor out here. So we have P inverse, open a bracket, you have 1 minus 2P and that can be equal to minus p. So automatically our p inverse will be equal to what? Minus p, dividing both sides by 1 minus 2p, open bracket 1 minus 2p. So this is our inverse, provided or given that p belongs to the set of real numbers. Now, we quickly answer question D on this. So this says, find the element of R under this operation that has no inverse. Yes, I want to believe as Muslims have come a question so that you have a function. You have been told that find the value that makes that function undefined. So what do? You just look at the denominator of that function, you equate to 0. The value you get or the root you have there will make that function to be undefined. Simple. So the same thing we do here. For this thing, for it not to have any inverse, it means it is not, because look at the inverse is what? The fractional inverse. It means it is not defined. So for it not to be defined, we just say 1 minus 2p can be equal to 0. Then minus 2p can be equal to minus 1. Right? So dividing both sides by minus 2. This cancel this. P can be equal to 1. So find the element of R under this. So the element under that will make it to have no inverse is half. Understood? We go to the last part of the question. The question says, calculate this. We are using this definition again. So we have, okay, this is a short question anyway, short. So we have 3. We are taking this, take this to be x, take this to be y. Do you get? So instead of, we are now having 3 minus 3 root 2 operating 5 plus 3 root 2. That can be equal to what? By this definition, write x first. 3 minus 3 root 2 plus y, this 5 plus 3 root 2. Then you have what? Minus 2, open a bracket. These two guys, they multiply each other. You have 3 minus 3 root 2. Close this. Then you have 5 plus 3 root 2. Yes, so this is how we move. So what do we do now? We have, if we add this together, 3 plus this will give me what? Will give me 8. This guy and this guy, they are gone, right? So you have minus 2, open a bracket. Let these ones expand yourself. 3 times 5, 15. 3 times 3 root 2. That's plus 9 root 2. Minus 5, minus 3 root 2 times 5. 3 times 5 will be 15. Minus 15 root 2. Minus root 2 times root 2. That will be minus 9. Root 2 times root 2 is 2, right? Yes, root 2 times root 2. That is root 4. Root 4 is still 2. So here we go, we have 8 minus 15 plus 9 minus 15. That should be minus 6 root 2. Then minus 18. So you have 8 minus 2 open bracket of what? 15 minus 18. That will be 6 root 2 minus 3. Right? So that can be equals to 8 minus 12 root 2. Then what? Minus 6. So what would that eventually be? That will be equal to 8 minus this. That is 2. The answer is 2 minus 12 root 2. And that can be equal to what? Factor out 2 here. So you have 2 open bracket 1 minus 6 root 2. So we are done, good as done. So thank you for staying with me on my channel. Please don't forget to subscribe, hit the subscription button, like each video you watch, then make your comments known. If you want to reach me, of course, you can make it known in the comment section, and I will get back to you. Thank you very much. See you some other time.